Alright, let's do some converging and diverging series. To sort of get stuff started with the numerical analysis assignment, this is numerical analysis 2, I want to sort of look at, I'm going to just sort of drag this over here just to sort of show you this is the example series that I'm going to use. Let's do just a little housekeeping here and move some stuff around. To use a slightly smaller monitor if we're doing my videos here. Now, the sequence, this is our n, of course, and the sequence is really straightforward. We're just going to enter the sum in, which is x to the end. And as you know, like this is, as this is written, this is technically a power series. So let's let x be a fixed number. Let's say x is going to be equal to, let's let it be less than 1, so we know this converges. So let's let it be 1/2. This is just something I'm doing to sort of do an example, and then you can go through the two series that are in the assignment. So I'm going to let x be 1/2. So x is not really a variable, it's a constant in this particular situation. And I'm going to enter 0.5. So I'm just going to bring the cell reference down, make it absolute. And I'm going to raise this to the n. And this is going to be my sequence. The double click there to get that all the way down. You see it plotted right up. And as you'd expect, this is less than 1, so it converges. And then you can sort of see what happens if we you see what happens at exactly 1, it's just sort of there, and if we make it 2, it explodes. But anything less than 1, we should get a nice convergent situation. And this is my sequence. Now the series is going to be the aggregation of all of these terms, adding them all together. That's the sigma, right? So I'm going to bring the first one over. The first term of a series is always equal to the first term of a sequence. That's just how it works, folks. So I'm going to then sort of build an aggregation of all of these terms. So you have to do like a little diagonal stuff here. I'm going to add this to this. And that's all I have to do. And send that down. That's it. Series and sequence. You see that this converges to 2. And this converges to 0. Hey, check that out. That matches my 1 over 1 minus r. You know, this is going to be 1 over 1 minus 1/2. That converges to 2. If I put this to 0.25, you see it converges. And make it like 0.8. You can explore. You can see that as you get closer and closer to 1, it's going to converge slower and slower. It should still be converging there, it's just I don't have enough terms. But, and of course, once you get to 1, it's completely a straight line. 0.99 would be just a little bit of a bend. Okay, so you guys get the point of this. This is how you're going to navigate part 1. Just coming up with a convergent and divergent scenario. I want to show you something that I'd like you to do. I'm going to set this back to 0.5 momentarily. On the divergent series, I asked you to put this on a secondary axis. I'm asking you to do that because this is a handy thing to do for some sorts of plots. To put this on a secondary axis, select the data set for this sequence right on the plot there. Right-click it and format data series. There's the secondary axis, and close that. You see what it does is it brings up, I now have two y-axes. This y-axis corresponds to the sequence, and this y-axis corresponds to the series. I personally don't like plots like this because it starts to get a little difficult to keep track of things, but they have their place in time. And we can go in and format each axis separately just by right-clicking on the actual numbers themselves. And you can go in and adjust You know, looking at this, it looks like, you know, I could get a better view if I sort of zoom in a little bit. So I'm just going to go to 0.6. So it's no longer automatic, it's fixed based on what I tell it. And you can sort of see it zoomed in a little bit. We can, I don't know, you need to see the bend. This is a little more resolved. That is how you put data on a secondary axis. I asked you to do that in the in part 1 of the numerical analysis assignment. That is it for part 1. Good luck.